Welcome to this explainer. We're diving straight into one of the most absolutely crucial topics in university-level microeconomics today, and that is elasticity. We're going to map out exactly how markets and consumers react when we start manipulating the rules of the pricing game. It's kind of like a giant puzzle, and we're about to solve it. Here's the tournament bracket we're tackling today. We'll start with the core concept, move right into price elasticity of demand, hit the total revenue test, tackle income and cross elasticity, check out supply elasticity, and wrap it all up with a victory revision.
So, think about the ultimate dilemma every single business faces. We all know the basic law of demand, right? Price goes up, quantity demanded goes down. But honestly, that's just not enough info for a rational business trying to maximize profits. The real question is, by how much? If a firm bumps its price by 5%, are its sales going to drop by a measly 2%, or are they going to plummet by a massive 200%?
But before we officially enter the arena, let me throw a bit of a paradox your way. Have you ever noticed that your local grocery store or, say, your favorite clothing outlet is constantly throwing those half-off sales just to get you through the door, but a gas station literally never does? You're never going to see a massive 50% off unleaded gasoline banner flapping in the wind just to drum up excitement, right? Why is that? Well, to answer that, we've got to master elasticity. It's basically the secret weapon to decode everyday pricing mysteries, and by the end of this explainer, you're going to know exactly why the gas station plays by a completely different set of rules.
Enter the elasticity coefficient. This right here is the official metric, the numerical power level of market responsiveness, if you will. To calculate it, we're looking at relative percentage changes, not the absolute numbers. It is simply the percentage change in the dependent variable, so the quantity demanded, divided by the percentage change in the independent variable, which is the price. Basically, you're asking, if a business shifts its price by exactly 1%, what is the exact percentage shockwave it sends through consumer demand? Let's do a rapid-fire example to lock this in. Imagine a business drops its price by 5%. Suddenly, boom, they see a massive 10% surge in the quantity demanded. You take that 10% quantity change, divide it by the 5% price change, and you get a power level of exactly 2. Now, because of the law of demand, price goes down, quantity goes up, this is technically a negative number, but economists usually just ignore the minus sign here for the sake of simplicity. An elasticity coefficient of 2 just means that for every 1% change in price, the quantity demanded reacts by double that amount.
The crucial thing to remember here is that price elasticity of demand, or PED, is basically a measure of responsiveness. It calculates exactly how sensitive buyers are to a shift in price.
Now, there's one super important rule to remember here. Because price and demand move in opposite directions, this formula will always spit out a negative number, but in economics, we analyze the absolute positive value. Let's put this into perspective with some real numbers. Imagine two different markets, Market X and Market Y. In both of these markets, there's an identical price increase of 6 Rand, jumping from 12 up to 18 Rand. But just look at how differently the quantity falls. Market X drops only slightly, from 40 to 36 units. You can think of this like a daily necessity, maybe bread. But over in Market Y, that exact same 6 Rand hike crashes demand from 40 all the way down to 16 units. That right there is the highly sensitive behavior of a luxury market, like maybe imported watches. This wildly different behavior happens because elasticity actually operates on a sliding scale, falling into 5 distinct categories. At one extreme, you have perfectly inelastic demand. That's a vertical line where quantity doesn't budge even a tiny bit, no matter what happens to the price. Moving down the scale, you get inelastic demand, where the coefficient is less than 1. Quantity responds, but it's pretty sluggish. Then we hit the midpoint, which is unitary. A 1% price change equals exactly a 1% quantity change. Beyond that is elastic demand, where the coefficient is greater than 1, meaning consumers are highly responsive. And finally, at the far extreme is perfectly elastic, a horizontal line where any price increase instantly kills the market, dropping demand to straight zero. So why does one good completely break the market while another barely causes a ripple? Well, it all boils down to these tactical determinants. The absolute biggest factor? Substitutes. If a product has a ton of substitutes, say mutton or chicken, it's going to be highly elastic. If the price goes up, people will just easily switch to something else. No big deal. But if it's a necessity or highly addictive, or there just aren't any substitutes, like salt or matches, demand becomes highly inelastic.
Moving on to stage 2, the total revenue test. Before we crunch the numbers, let's set the ground rules. Total revenue is just the price in rands multiplied by the quantity sold. Sounds simple, right? But remember, a firm doesn't get to dictate both of those variables. If they change the price, the consumer decides the new quantity. And since they move in opposite directions, a price hike doesn't automatically guarantee a revenue increase.
Now, what's really interesting here is looking at these 5 categories side by side. You can see exactly how the elasticity coefficient completely dictates what happens to a firm's total revenue when prices change. On one extreme, right at the top, we've got perfectly inelastic demand where the coefficient is exactly 0. That means consumers will buy the exact same amount regardless of the price. Think of life-saving medicine. Then, on the absolute other extreme at the bottom, perfectly elastic demand means even a tiny fractional price increase will kill the market completely, dropping the quantity demanded to 0 because there are just infinite perfect substitutes out there. Which brings us to the ultimate business question, doesn't it? If a company decides to hike its prices, will it actually make more money or will it just completely ruin its sales? Let's solve that mystery in part 3, the total revenue test. The maths here is beautifully simple. Total revenue equals price times quantity. What we're doing is analyzing how the size of this total revenue box changes in South African rand when prices shift. Imagine drawing a box on a graph. The height is the price and the width is the quantity. It's basically a constant tug of war. When price goes up, the height of the box increases, but thanks to the law of demand, the width shrinks as people buy less. The total revenue test tells us exactly which of those forces is stronger.
And this, right here, is where we finally resolve our gas station paradox. If you have an inelastic demand, like gasoline, increasing your price causes you to lose very few customers, so your total revenue actually goes up. But if you have elastic demand, increasing your price scares away so many consumers that your total revenue box shrinks and goes down. So if a gas station actually threw a huge sale and dropped their prices, their total revenue would actually fall. There's absolutely zero incentive for an inelastic market to offer discounts. None.
Basically, consumers are insensitive to the change. If petrol goes up to 23 rand a liter, yeah, you might complain, but you still have to drive to work. The price went up a lot, but the quantity demanded only decreased a tiny bit, so the total amount of rand coming into the petrol station results in a massive net gain. Dropping the price just wouldn't bring in enough new drivers to make up for the lost revenue. Conversely, if it's an elastic good, price and total revenue move in opposite directions. A higher price scares away so many buyers that the total revenue box shrinks. Think of a 1,000 rand branded jacket. It's highly elastic. A 20% discount might convince double the amount of people to buy it, massively expanding that total revenue box and bringing a flood of rands into the till. And honestly, that is exactly why elastic products go on sale all the time.
If you ever get stuck trying to remember this in the heat of battle, try this physical trick from the source material, the I pose. Imagine yourself standing up right now. If a product's price goes up, raise one hand in the air. If the total revenue also goes up, raise your other hand. You're now standing straight up with both arms pointing to the sky. You literally look like the letter I, and I stands for inelastic. If one hand goes up and the other goes down, well, you don't look like an I, so it must be elastic. It is a brilliantly simple way to lock the total revenue test into your memory.
Let's switch gears for part 4, Income Elasticity of Demand. Because price isn't the only trigger. What happens when we shift our focus from the price tag to the consumer's paycheck? How rich or poor a consumer feels drastically changes what they put in their shopping trolley. So, we look at the formula for income elasticity, which calculates the percentage change in quantity demanded relative to a percentage change in the consumer's income. Notice we've swapped out price for income in the equation. This is incredibly valuable for a business owner trying to navigate a recession versus a booming economy. We basically want to know if your paycheck goes up by 10%, by how much does your consumption of our specific product change? And here's how this plays out in the real world. If the coefficient is positive, it's a normal good. As income grows, we buy more of things like craft beer or scented candles. Now, if that positive number is greater than 1, it's a luxury item, meaning you buy disproportionately more of it as you get wealthier. But if the coefficient is negative, it's an inferior good. As your rand increases, you abandon that budget cabbage for, say, a premium steak. The cabbage is an inferior good. Not because it's bad for you, but because economically, you simply outgrow it.
Then we have cross-elasticity, and this formula asks a really fascinating question. How does a price shock in one market, let's call it market Y, ripple over and change the quantity demanded in an entirely different market, good X? To find out, we just divide the percentage change in X's quantity by the percentage change in Y's price. Once again, that mathematical sign is your best friend. If the cross-elasticity coefficient is positive, the goods are substitutes. For instance, if the price of margarine jumps by 50% and the demand for butter rises by 25%, that positive 0.5 coefficient proves they are substitutes for each other. Conversely, if the sign is negative, they are complements. If cell phones suddenly get 50% more expensive and the demand for SIM cards falls by 25%, that negative coefficient shows us these two products are completely locked together in the market.
Now for stage 4, the mirror match, price elasticity of supply. The law of supply tells us that as price goes up, quantity supplied goes up. But how fast can producers actually react? The absolute biggest constraint here is time. In the short run, supply curves are usually highly inelastic. I mean, if tomato prices skyrocket today, a vegetable farmer can't just instantly spawn a new harvest by tomorrow morning. You just can't rush nature. But if a firm has excess capacity in a factory or stockpiles, or if we look over a longer period of time, supply becomes way more elastic.
And finally, stage 5, the victory screen, for our ultimate revision.
Consider this your ultimate revision matrix, locking in every single definition, formula, and point method we've covered today. You definitely want to pay special attention to that mathematical science column. Just to recap, price elasticity is always negative, but we analyze it in absolute terms. Cross elasticity absolutely relies on the sign to identify substitutes or complements. And income elasticity uses the sign to separate normal luxury goods from inferior necessities.
So, as we wrap up this explainer, I want you to look at your own business, or even just the shops around you. Are they actively calculating elasticity to maximize their South African rand, or are they literally just crossing their fingers and guessing? Understanding whether your product is a daily necessity, a luxury, or easily swapped for a substitute is quite literally the difference between a pricing strategy that builds an empire and one that destroys it. The maths doesn't lie, but ignoring it, that will for sure cost you.